Hey pre-calc, this is the second part of section 1.3, lesson 2, all about rational functions. So I kind of left off with this same technique of I need to factor first on the denominators. So I've got a difference of squares here. I've got a trinomial right here that can be factored as a quadratic. So if you check x squared plus 4x plus 4, that actually is going to be x plus 2 times x plus 2. I'm not going to show the work for that because I think it's pretty clear to just do a guess and check on it and verify that that works. The second one's going to be x minus 2, x plus 2. And you got 3 times x minus 2 over here. There's our next example. So what do we need? Well, this one's got 2x plus 2's, which means everybody's got to have 2x plus 2's. So we need another x plus 2 being multiplied right here, both bottom and top. And then this one also needs a double x plus 2. Now, instead of rewriting x plus 2 twice, we know that x plus 2 written twice is going to be x squared plus 4x plus 4. So what I'm saying is, you got 2x plus 2's here. You got 2x plus 2's here. You do have 2x plus 2's here, but it's the same as multiplying by x squared plus 4x plus 4. So I'm actually going to do that up top because I'm pretty sure I'm going to have to expand the polynomial and combine with the other elements of the two fractions. All right, I know, this is getting really wonky. There's the fraction. It's okay. But I don't think we're done yet because this has an x minus 2. So we need x plus 2, x plus 2, x minus 2. X plus 2, x plus 2, x minus 2. X plus 2, x plus 2, x minus 2. All right, so a lot of algebra to be done now. This first one's going to be 2x squared minus 4x plus 1x. It's going to be minus 3x plus, well, minus 2. Okay. Minus 6x times x, 6x squared. And make sure you distribute that negative through twice. It's negative 6x times positive 2. And then it's going to be 3 times everything inside here. So plus 3x squared plus 12x plus 12. And then one denominator on the bottom is going to be x minus 2, x plus 2, x plus 2. All right, and basically at this point it's an algebra 1 type scenario where, can I collect the like terms? Yes, I can. So 2 plus 3 is 5, minus 6 is negative 1x squared. Negative 3x minus 12x is negative 15x. But these 12x's cancel out, and you're just going to be left with negative 3x. Canceled, negative 3x. And then plus 12 minus 2 is plus 10. Now, sometimes textbook writers are very slippery with their examples. And it seems like, yay, we got it all done. That's great. But this polynomial, I got a sneaking suspicion that it can factor and possibly cancel out with one of these guys on the bottom. So let's figure out what negative 1x squared minus 3x plus 10 can maybe factor down to. So, the middle, think about this. What multiplies to give me negative 10 and adds up to give me negative 3? How about negative 5 and positive 2? Yeah, so factor out, and you know what, I want to get that negative out of there. Negative 1x creates a positive x here and a positive 5 there. Take out a 2 here, and you get plus 2 times x plus 5. So over here, these two come together. Negative 1x plus 2 times x plus 5 over all this. Oh, look at this. Negative x plus 2. If I take a negative 1 out, you can randomly factor anything you want out. It's just like dividing. I guess you can't factor out a 0. But this negative 1, if I divide out the negative 1, you got a negative 1 out here and an x minus 2. So our final answer? Sorry. There it is. Whew. Okay. You know, these are a lot more involved than I initially thought they would be. That's okay. Number 53. Ooh, fractions galore. I got a feeling I just want to kind of like take this large fraction and rewrite it as numerator, and just write it horizontally, divided by denominator. I don't know why, that just feels better. All right, common denominator here, s and r would be multiply that by r, multiply that by r, multiply that by s, multiply that by s. All right, rs is our new common denominator for this fraction. So r squared plus s squared divided by rs. There we go. Let's make this one fraction too. So we need an r squared here and an r squared here, s squared here, s squared there. So that's divided by r to the fourth minus s to the fourth all over r squared, s squared. Now your next move on this is, in order to divide fractions, you can flip the second and then multiply the result. Oh, and the r to the fourth minus s to the fourth is a difference of squares. All right, so the bottom has r to the fourth minus s to the fourth. I'll write it in. But it factors down to r squared minus s squared times r squared plus s squared. Sorry, I got to make this clear. R to the fourth minus s to the fourth is a difference of squares. So the square root of that, r squared. Square root of that, s squared. Minus plus. Sorry, I'm kind of going off the rails with this waterfall mathematics. All right, it works? It works, yeah. So now we can replace r to the fourth minus s to the fourth with this wayward being here. Which is super helpful. We've got cross cancellation of the r squared plus s squared here and here. We've got some cross cancellation here. R squared over r would be 1r on the top. S squared over s, same deal, different variable. Which gives us rs over r squared minus s squared. If we're supposed to simplify the expression, then technically I guess they want us to continue factoring this difference of squares situation. Because this is r times r, and this is s times s. All right, let's look at 57 and see what we've got here. 5 over x, okay. I'm going to find a common denominator on top. We're just making sure that the numerator has a common denominator. Ooh, that's a weird statement. The numerator has a common denominator. So you get 5a minus 5. Hold on, can you see this whole thing? Yeah, you can. 5a minus 5 minus 5x minus 5 times minus 1. That's plus 5. All of that is divided by x minus 1 times a minus 1. And instead of rewriting it all over x minus a, I am going to say divided by x minus a over 1. Actually, instead of doing divided by x minus a over 1, I'm just going to flip it and multiply right away. I'm just going to multiply by 1 over x minus a. So instead of dividing this entire thing by x minus a, I'm going to take this entire thing times 1 over x minus a. So when we look further, negative 5 plus 5 is 0. Then you've got 5a minus 5x times 1. Well, that's going to be 5a minus 5x. All over x minus 1, a minus 1, x minus a. Now, did you catch what they're doing here? They've got a 5 here and a 5 here, but they also have the structure of a minus x, which is the opposite of x minus a. So to create cross-cancellation here, or just simplification, I can factor out a negative 5. So if I divide this by negative 5, I get negative a. If I divide this by negative 5, I get positive x. See, now I've matched x minus a on the bottom. This is technically x minus a. So x minus a divided by x minus a simplifies. So here's our final answer. Negative 5 over x minus 1 times a minus 1. So, I had one more example. Maybe I can race through it. Let's try. All right, it's number 65. Yeah, we got room. Root a minus b. Root a minus root b over a squared minus b squared. It's a weird task here. They say rationalize the numerator, which is interesting because people usually don't do that. But sometimes just being able to, follow instructions is a task all its own. So to rationalize something means to write it without any radicals. So when you see root a minus root b, you got to go back to that concept of the conjugate. The conjugate is basically identical statements with an opposite sign in between. Because what it does is it creates a difference of squares that will eliminate the roots and have no middle term. All right? So you're multiplying this times root a plus root b. But you got to multiply it by top and bottom, otherwise you kind of disrupt the equilibrium of what a fraction is. When you do that, you create a difference of squares, which means you can square the first a, square the last b, and it's got a minus in between. Difference of squares factoring, if you remember. Additionally, this is itself a difference of squares. It's a minus b times a plus b. Don't forget the root a plus root b over here. We got cancellation of the a minus b, leaving us with 1 over a plus b times root a plus root b. All right, thanks for watching.